B. Joseph Pine. The book, Infinite Possibility, Creating Customer Value on the Digital Frontier. Joe, in your book, you offer many examples and references to games, events, places, things, a lot of resources that demonstrate your Octant model for the cosmos incogniti, or what you're calling the multiverse. Is your book merely combining a collection of information already presented by others, or do you believe you're bringing something new to light?
Well, I always like to say, Michael, that I don't invent this stuff. I discover what people are doing and what companies are doing, and then try and develop frameworks to make sense of it. And that's always been the case really until this framework. This framework basically emerged out of blue sky thinking, in not thinking about any particular company or examples, but just in recognizing what digital technology does to the fundamental dimensions of the universe, of time, space, and matter. And once you could see that it basically reverses each of those, that you go from matter to no matter, from atoms to bits, that you go from space to no space, from real places to virtual places, and you go from time to no time, from actual events unspooling before us to autonomous time, in any way that you play with time in some way that doesn't follow the linear flow of time. And so it is a new to the world framework that I don't think has ever been thought of before in quite that way, and hopefully it does add a lot of value to companies to help them think through what they can do today to create value on the digital frontier.
And how does your book incorporate or demonstrate in and of itself the cosmos incogniti?
Well, one of the a couple of ways. One, we say in the book that do not interpret it as a plea to abandon reality, because reality will now and forevermore provide the richest of experiences, and I think that includes touching and feeling an actual physical book, right? But you can get it on ebook. You can get the virtual version of it, but recognize also that virtuality, as we call it, the opposite of reality is virtuality. And virtuality does not require actually digital technology to make it happen. Virtuality has always been around, and the prime example is books. As you think about how books, especially fiction books, but even nonfiction books, can allow us to escape into our mind's eye, where we can visit places that do not exist in reality, and that's what virtuality does. That's what books enable. So hopefully that's the case with this particular.
Some technologies you describe, like the touchable holograph, evoke visions of Star Trek's Next Generation's holodeck. How much science fiction, in your estimation, has influenced the science fact you're describing?
A lot. A lot. There are many people, in fact, that credit Star Trek in particular with inspiring what they're doing. Homaru Kantu is a gentleman a chef, one of the molecular gastronomy chefs, who's got the restaurant Moto in Chicago. And he created edible paper that you can print through an inkjet printer, and then create this. And what he wants to do is work with food at the molecular level rather than at the sort of item level of that. And he credits the Star Trek replicator for doing that. Neil Gershenfeld is a computer science professor at the MIT Media Lab. And he also talks about being inspired by the replicator. He wants to create fab labs that can replicate anything. He talks about how what it is basically is treating atoms like we normally treat bits, that we can actually program atoms like we can today program bits with computer systems. And the holodeck also has inspired a lot of people in virtuality to think about it. I think the original conception of virtuality, of virtual reality, inspired the holodeck, but then the holodecks inspired others to recognize how far you could go, because one of the key things is that it's not just a visual thing, you can touch and feel it. And that's what these Japanese researchers are doing, is creating holodecks or holograms that essentially you can, it's as if you could touch and feel them, and it's an amazing invention.
Now, in your book, you describe virtuality, but saying that it's always based on reality because we are in the real. Do you foresee that we're anywhere close to digitizing the atoms into bits for a real virtuality experience, like in Tron?
No. I think that is going to The tried aspect is going to remain a science fiction. I think the Matrix will remain science fiction, but you don't know, how far things will go. But it will certainly be almost as if that stuff will be true. We'll be making so much progress in the direction that we're going that you may not be able to make a distinction between what's happening there and what we're able to accomplish in this world, because we are limited only by our imagination.
And your book, it lends itself to possibility of getting into academia. Do you have any aspirations of having your topic of infinite possibility and the multiverse and the Octant Model getting into collegiate curriculum?
I certainly hope so. I mean, all of our books, my book, Mass Customization, the Experience Economy, in particular, are used by a lot of people in universities. A lot of professors assign them. It's one of the reasons why the books keep selling year after year after year. And I think that same possibility is there for infinite possibility because, no pun intended, it does provide a sense-making tool. It allows us to make sense of what's going on with this explosion of digital technology and help us to categorize it. And I think that's something that academias tend to like. I've always before worked with a 2x2, where we get 4 quadrants in that. And academics love 2x2s. It's just easy to categorize, mutually exclusive and all that. And a 2x2 takes it to another level, makes it much more complex. It's an admittedly complex model of the multiverse. But I think it does reward those who will take the time to learn it, to internalize it, so they can then use it in how they make sense of the world.
Joe, do you believe your Octant model touches on the 4th dimension, the introspective?
When some people use the term 4th dimension, they actually mean time. That they think of space as the first 3 dimensions. But each of these 3 dimensions of the universe, right, the fundamental dimensions of the universe is in fact a trinity, right, of time, space, and matter. And it's a true trinity in the sense that if you take away any one of those, you've got nothing left. It's not like a triad or any other tripartite, any other way you can break up 3, where you can look at 3 parts. In this case, a true trinity is one where you have nothing left if you take away any one of them, and that's the case with these. That you take away time, and it's a measure of change, and nothing happens inside of space and matter. You take away matter, there's no way to even constitute of space, and nothing changes, and therefore time doesn't exist. You take away space, and there's no place for the matter to be, or for the time to occur, and so forth. Well, each of those is in fact a trinity of trinities, right? So each one of them has 3 dimensions. So space we usually think of as length, height, and width. It has 3 dimensions. And so people often refer to time as the 4th dimension, the space-time continuum there. But time itself has 3 dimensions, of past, present, and future. And matter has 3 dimensions of mass, the physical things, as well as energy, which you can break up into potential and kinetic energy. So they all have 3 dimensions. They're all a trinity of trinities. And together they comprise all that exists in the universe. And so there is nothing outside of that. There are people that talk about string theory and superstring theory and supersymmetry and all that, with 11 dimensions of the universe, of which we can only see 4, and it's unprovable. But there is another possibility. People are also talking now about the fact that if you drill down into matter, if you go to, you get down to the atomic level of atoms, you get down below that in the subatomic level of quarks and muons and bosons and all this sort of stuff, that we have discovered, and they just announced this week, they discovered yet another particle down at that subatomic level, at the quantum level, in essence. But there are those that believe that there's a level below that, a level that we have not yet discovered, that may also be undiscoverable and may be unprovable, don't know yet. But the level below that, there's zeros and ones. Right? And I view it as Occam's razor. The easiest way to think about the creation of the universe is that, in fact, it is a giant computer.